Alrighty, so I'm going to begin. Today we're going to be looking at Lewis dot diagrams. Now I have a pretty good feeling that the vast majority of you probably know something about this already, so we can probably zip through it pretty quick. And then we're going to be looking at ions as well, and I'm not sure where you're at with ions, so we just want to make sure everyone's sort of up to speed. Here's a picture of Niels Bohr. This is the guy that came up with the diagrams. Can you tell me what element this is up here? What does that mean? It is, you're right, it is number 20. How do you know that, Christian? Because it says 20 protons and 20 neutrons. How many electrons would there have to be? 20. And you could count them. 1, 2, full outer shell, that's 8, that's 10. Another outer shell, that's 18, plus 2 more is 20. And it's? Calcium. Okay, so Bohr models can be, pardon the expression, a little boring. Not even a smile at anyone. They're kind of hard to draw. There's lots of unnecessary details. They take up a lot of time, and they're not particularly fun. So along came this guy, Gilbert M. Lewis. Clearly the picture was taken during the month of November. And he said, you know what? Why don't we just simplify the drawing? Let's just draw the valence shell. So in other words, this giant calcium thing simply becomes this. Ca replaces all of this stuff. Okay? And why is this good, or why is this useful? Well, because only the valence electrons are involved in bonding. Let me make that a bit bigger for you. This works because only the valence electrons are involved in the bonding. The inner shells are full, happy. As long as we know we see these two outer ones, we don't really care about the inner ones because we know that they're already happy. Here's what I'm going to do, because that zoomed in way too much. I'm just going to make this bigger. There, that's better. Okay, does that make sense? So how do you do these Lewis dot diagrams? Well, all you have to do is simply draw the valence electrons. Draw the outer shell. How many people know we've seen that before? Just give me a quick, yeah? Seen those before? Either you're that lazy you can't give me a little wave, or you've never seen those before. Yes, am I right, Sadie? You've seen these in grade 9, right? Okay. Good. Okay, so what I'd like you to do now is you've got that little worksheet there. BLM just stands for Black Line Master. It just means something that can be photocopied really nice. So I just want you to do the first two. Okay, they talked about it in the front page there. No sense me stealing Troy's when I've got lots. A Lewis dot diagram is a convenient shorthand method to represent an element and its valence electron. The arrangement of elements in the periodic table yields more information about the electronic structures of atoms and how those structures can help predict the properties of many elements. The arrangement of valence electrons is key to understanding how atoms behave in a chemical reaction. Lewis dot diagrams are diagrams in which dots or other small symbols are placed around the chemical symbol of an element to illustrate the valence electrons. Each dot represents one valence electron, okay? In the dot diagram, the element symbol represents the core of the atom, the nucleus plus all the inner electrons, which is what I was showing you here when I drew that red circle. Atoms in the same family will have similar Lewis dot diagrams, except for helium, which has only 2 valence electrons. Okay? So for example, what's right above calcium on the periodic table? There's calcium. Magnesium is right above it. How many does it have in its outer shell? How many does magnesium have in its outer shell? Also 2, right? So it looks identical to calcium with the exception that it's just Mg, and then the 2 circles are the same. It has the same number of valence electrons, okay? Here are some sample ones right there. All I need you to do is these 2 sheets right now. 5-6 and 5-7. Okay? That should take you about, I'm going to guess, about 10 minutes, if that. Good day, sir.
Hey, how are you?
Good.
Do you have one of these?
No, I don't. Okay, so ions. You've probably heard the word ions. Maybe you know what they are. Maybe you have no idea what they are. I'm going to talk about them quickly here. So an ion is simply an atom that is either taken in or given off electrons to make their outer or valence shell full. They are now happy. When they are in element form, they're not particularly happy. We've talked about things like this. For example, magnesium has an atomic number of 12. What does that mean? It means it has 12 protons and 12 electrons. Okay? What's its overall charge? Protons are positive, electrons are negative. Its overall charge is a big fat?
0.
0, exactly. But it's not happy. It's got 2 in its outer shell, and I would really like to get rid of those 2. Right? It wants to give off 2 electrons so that its outer shell is full. When it does give off those 2 electrons, then what do we have? Well, now we still got 12 protons. Can atoms give off protons?
Yes.
No.
No.
Cannot give off protons. They're locked in the nucleus. Sorry to be so. So we would only have 12 protons. If it's given off 2 electrons, now it's only got 10. What's the charge now if we've got 12 positives and 10 negatives? What's the overall charge? Christian? Huh? Exactly. Come on, man. 12 protons. Yeah, relax but listen. 12 protons, 10 electrons, 12 positives, 10 negatives. I have an overall charge of 2 what? 2 positives. Okay? Here's my charge thingy. That's no good. So this creates what we call a stable ion. It's happy. It's giving off. Don't close your books. Don't close the book. Don't close the books. It's giving off those 2 electrons. It now has a full outer shell and a charge of, I got this wrong here, don't I? What should that be? 2 positive. I went the wrong way. Sure. Just, I need you for like 3 more minutes. Just listen. I know it's near the end. I know that. I get it. I'm going to try. I will be done before break. I promise. Okay? The charge is 2 positive because now I have 12 protons, 10 electrons. I got way more positives than electrons. Okay? What does the Lewis dot diagram look like now? It looks like this. Notice that magnesium has gone from this. It got rid of those. Now its outer shell is the next one inside, kind of like the Ukrainian nesting dolls. How many in its outer shell now?
8.
8. Are these the same ones that were there before?
No. No.
Well, they were here, right? They were on an inner shell. We just didn't see them because we didn't have to. They weren't the outer shell. You can only see the outside doll, right? They were still there. Now it's the outside shell. Now we see all 8. Why do I need this little thing in the corner here? Why do I need the 2 positive? That's the charge. You have to know that. That's the charge. This is referred to as the Lewis diagram of the magnesium ion. Okay? You should be able to do the next 2 pages now. Okay? Especially if your book was open, it'd be a lot easier to do that. Yeah. Did you? Alright. I'll give you some time tomorrow to do the next 2 pages. Miss House and I will circulate and make sure we're all good. Tomorrow we gotta talk about ionic bonding.
Yeah.
Thank you. Yay.